Hello, everyone, and welcome to the SDV Monthly Readout for March, where the product team shares announcements and updates. Each month, we go over some recent SDV highlights and give you a sneak peek into what we're working on. So my name is Neha Papke, and I am the head of product at Datacebo. Today, I am excited to walk through our updates for March of 2026. So I want to start out with one big highlight of the month that the team is very excited to share with you all. Synthesizing complex schemas with composite keys. So SDV Enterprise now provides support for composite keys, which is one of the most requested features by our enterprise users. With SDV Enterprise, you're now able to create synthetic data for complex schemas with composite keys. Even if you have many tables with connections between them, SDV Enterprise can learn patterns and create synthetic data that is completely valid with referential integrity. So let's take a look at that. Kind of going back to our overall goal, we want you to be able to create valid, high-quality synthetic data for any relational database. This means that we provide support for all the features that a relational database typically has. So I've listed some of them here at the left. Primary keys, foreign key references that link back to those primary keys, referential integrity between all the tables, null values, composite keys, and more. So this month, we're focusing on composite keys, but keep in mind that composite keys can occur with all the other features. So you can have a primary composite key or a foreign composite key, and so on. So just as a quick refresher on composite keys. A composite key is when multiple columns act together to be a key for the table. So this could be a primary key, which uniquely identifies every row. So in our example here at the right, we have a table about patient visits to a particular doctor's office. And the composite primary key here is the patient ID column and the date column together. That means that the combination of these two values is unique, and it uniquely identifies every record in the table. It uniquely identifies a patient visit. But within each individual column, the values are allowed to repeat. So a patient ID can appear multiple times because a patient can come back and visit the doctor's office multiple times. And a date can also appear multiple times because many patients can come into the doctor's office on the same date. So it's the combination of the two, the patient and the date, that uniquely identifies a visit. So when we create synthetic data for these kinds of composite primary keys, we make sure that in the synthetic data, the combination is always unique. But there's more to it than just that. SDV Enterprise also learns the patterns inside each of the individual columns. So for example, every patient ID should follow the right format, which in this case is P dash and then some digits. And we expect that patient ID to repeat a reasonable number of times, which means the patient came back a reasonable number of times. And then for the date column, this is the date time, we expect that the dates occur within a realistic range and also follow a realistic distribution. So SDV Enterprise makes sure to learn these patterns individually in the two columns, but then when put together, it also makes sure that that composite primary key is always unique. Composite keys can appear in many different forms throughout the data set, and that's what ends up creating complex schemas. So we're happy to say that SDV Enterprise can accurately address all these types of complexities that can come up. And now I want to go over a few types of complexities we've seen in enterprise databases. And keep in mind that everything I'm about to show you can be addressed by SDV Enterprise. So a first example is when you have a composite primary key, but in addition to that, one of the columns inside of it is actually a foreign key reference to another table. So in this example, remember how we said that a patient ID can repeat multiple times because a patient can come back multiple times to visit? Well, a patient ID itself can be a foreign key reference into another table that is just related to patients. So that means that each patient ID down here in the patient visits table refers to a unique patient up here in the patients table. So in a sense, you can think of it as an overlapping column of sorts. This patient ID column is part of a composite primary key, but it is also a foreign key. And so this concept we see is pretty common when you have composite keys in databases. The concept can also happen with multiple columns. So now we have a new table called lab results, which stores all the ordered and finished lab tests for a particular patient on a particular date. So it has a composite primary key with 3 columns now: the patient ID, the date, and the lab test. So this is the test that was ordered for that patient on that date. And all 3 values together uniquely identify a lab result. So in this table, it's the patient ID and date columns together that act as a foreign key and reference a patient visit. So essentially what the schema is saying is that patients can visit, and for each visit, there can be one or more lab results that are associated with it. Things like the A1C or cholesterol HDL tests. And so all of those tests correspond to that one visit. So I've seen schemas where this concept can actually cascade along a chain of tables. So you can have a lab results table, which has a couple columns that references the patient visits table. Then you have a patient visits table with a couple columns that references a patient's table, and so on. So there's combinations of columns here that are involved in being both the composite primary key as well as being a foreign key. Another complex example is a bridge table. So in databases, bridge tables are commonly used to connect 2 concepts in a many-to-many fashion. So in our example, we have a table of practitioners who work at the doctor's office and a table of patients who go there. Now, a practitioner can have multiple patients, and a patient can actually have multiple practitioners as well for different specialties. So to add connections between these tables, you typically use a bridge table. So in this case, practitioner-patient. So this identifies every practitioner that's associated with every patient, kind of all those combinations. But there's a catch here. In this bridge table, we shouldn't list the same practitioner for the same patient multiple times because that doesn't make any sense. So it's the combination of practitioner and patient IDs that need to be unique. So typically in a relational database, we'll see this set up as a composite primary key. So that means that the practitioner ID and patient ID together form the primary key and are unique. But at the same time, each of the individual columns in this primary key are actually foreign keys into different tables, which is what makes this particular example complex as well. So in all the schemas I've shown so far, they are supported by SDV Enterprise. And in fact, we offer an SDV guarantee for complex schemas like this. So first, you can supply your composite keys directly in the SDV metadata. So this allows you to visualize and control which connections SDV knows about. The composite keys that you add can be involved in any of the connections between your tables. Just like we've seen, this can be complex. And finally, SDV Enterprise will always maintain referential integrity and cardinality, which makes your synthetic data realistic despite the complexity of the database. So we hope that that was a good primer into composite keys, and we're really excited for SDV Enterprise users to begin using this feature. To finish off our monthly, I want to talk about a new project, an upcoming project in our roadmap. As a sneak peek, I want to share that our team is working on a product called Atlas. So Atlas is a one-stop shop, scaffolded solution for building predictive ML models. Under the hood, it uses synthetic data to improve the quality of these predictive models. And like its name suggests, Atlas helps you navigate these complexities of building a predictive ML model, especially when it comes to synthetic data. So it sets up a whole workflow for you, like we've illustrated here. And it adds synthetic data at precisely the right stage in order to improve the ML model. So in summary, Atlas uses synthetic data to create highly accurate models, especially when data quality issues plague you. Here's some benefits of using Atlas. First, Atlas creates more accurate ML models because it incorporates synthetic data into the training process. We call these Atlas models. And you can create them for predictive tasks like binary or multi-class classification problems or regression. Atlas also works with multi-table datasets, It has an entire workflow to create labels, features, and ML models for multi-table data. And then it even adds synthetic multi-table data during the right times. And finally, Atlas presents your success metrics to you. So you'll be aware of how much improvement you can get by using an Atlas model. It shows you the ROI of using Atlas, and by extension, the ROI of incorporating synthetic data into machine learning. So if you're interested in piloting Atlas with us, please get in touch. You can fill out our form on datacevo.com. And with that, I want to thank you all for tuning in to the March update, and I look forward to seeing you next month.